Hello, my math free scholars. So we've learned how to simplify rational expressions. Today we're going to learn how to multiply rational expressions. So you can see I've got some examples down here of what that would look like. So we learned that a rational expression looks kind of like a fraction with these trinomials and binomials, sometimes monomials, like over here, this one mixed in. But now you can see we're putting a multiplying in between two of them. So we're kind of combining things together now. So before we get into this, I want to give you the steps that you're going to follow in order to be able to multiply rational expressions. So your first step is factor. And again, I know you guys don't like that step, but we have to factor these in order to be able to simplify them and multiply them. So I gave you a hint out here. You're going to use either greatest common factor, diamond method, factor by grouping, the box method, or difference of squares to come up with your factors. Okay, once you factor, you're going to cancel out your common terms. Then your third step is to multiply. And your final step is to state those restrictions like we've been talking about. What would make your denominator equal to 0? So identify all your x values that would make your denominator equal to 0. Now, these all should look familiar. This is what we did before. Step 1, factor. Step 2, cancel out common terms. And this last step, state restrictions. The new step here is this multiplying, okay? So I want to just remind you that when you're canceling out and you're doing it with fractions, you can cancel out top to bottom, and you can also cancel out diagonally. So like if I have something in common in this numerator and this denominator, I can cancel it out. Or vice versa this way, in this denominator and this numerator. So just remember that you can also cancel out diagonally when you're multiplying. So for these examples here, it says multiply and state any restrictions on the variables. So the first thing we need to do is step 1, we need to factor. So let's look at number 1, and we're going to factor x squared plus x minus 6. Okay, I'm going to use the diamond method to do that. So 1 times negative 6, I need to get a negative 6, and it needs to add to give me a positive 1. All right, that's going to be a positive 3 and a negative 2. That gives me negative 6, and it gives me a positive 1. So this is going to be x plus 3 times x minus 2. I factored that top one. And then I still have that x minus 5. It won't factor any further. It's as simple as it can get. Times, okay, x squared minus 25, that is a difference of squares. So I have a difference, a minus in the middle, and then I have x times x gives me x squared, and 5 times 5 gives me 25. So both of those are perfect squares. So this factors as x plus 5 times x minus 5. Okay, and then we have x squared plus 4x plus 3. Again, we're going to use the diamond method. 1 times 3 gives me a positive 3, and then I need to get that positive 4 in the middle. So to multiply to get 3 and add to get 4, that's going to be a plus 3 and a plus 1. So I come down here, and this is going to be x plus 3 times x plus 1. Okay, now we have factored each piece that we can factor. Next, we cancel out common terms. So I'm going to look top to bottom here and see if I can cancel out anything. I can't. I'm going to look top to bottom here. I don't have anything in common. Okay, what if we look diagonally this way? You can see that we have an x plus 3 and an x plus 3. So we can cancel those out because they are diagonal with each other. Okay, if I look diagonally this way, I can cancel out x minus 5 and x minus 5. Okay, now there's nothing to cancel with this x minus 2 diagonally or up and down. There's nothing to cancel with the x plus 5 diagonally or up and down. And there's nothing to cancel with the x plus 1 diagonally or up and down. So now I can move to step 3, which is multiply. So on top, we're going to have x minus 2 times x plus 5 over what's left on the bottom, x plus 1. Now, you do not have to multiply this back out. You can leave it in its factored form, okay? So once we get that answer, we have to list our restrictions. What can x not be equal to? Now remember, to get those, you go back to where you factored the denominators. So here's this denominator. In order for x minus 5 to equal 0, that means x would have to be 5. So x cannot equal 5. Then we move to this one. X plus 3 equals 0. That would be a negative 3. And then what would make x plus 1 equal to 0? That would be if that's a negative 1. So I've listed my restrictions and I've come up with my answers. And that's how you do number 1. Okay, let's look at number 2. A minus 4, I can't factor that any further. 7, I cannot factor any further. Okay, 7a plus 49. Okay, there's not a minus in there, so it's not a difference of squares. But do 7 and 49 have anything in common? They do. They have a 7. So I could take out a greatest common factor, and that will leave me with a plus 7 over, and then a plus 7, I can't do anything with that. That's as simple as it gets. Okay, so we've factored. Now we're going to cancel out common terms. Okay, top to bottom here, I can't cancel anything. Top to bottom here, I can cancel the a plus 7. Okay, diagonally this way, there's nothing to cancel. Diagonally this way, I can cancel out those 7s. Okay, so you can see here that the only thing we're left with is a minus 4. Everything in the denominator canceled out, and the only thing left in our numerator is a minus 4. Okay, now we list our restrictions. What can a not be equal to? So we go back to our denominator. Well, this 7 doesn't have a variable, so I don't have to worry about that. But this one, a plus 7, what would make this part equal to 0? That would be if a is negative 7. So my a cannot be equal to negative 7. Okay, let's look at one more example in this video. 1, that's as simple as it gets, over p plus 3, I can't factor that anymore. 10p squared plus 20p. These two have a 10 and a p in common. So I can take out a 10p, which will leave me with p plus 2. Over, I still have that 10p on the bottom. I can't do anything else with that. Okay, so now that I've factored, we determine what we can cancel. All right, top to bottom here, we can't cancel anything. Top to bottom here, we can cancel the 10p. Now, can I cancel anything diagonally this way? No. What about diagonally this way? No. Don't try to cancel just those p's. It's p plus 3 and p plus 2. So those are two different things. I can't cancel them. All right, so now we multiply. 1 times p plus 2, that's p plus 2. And then p plus 3, this is like having a 1 over here because everything canceled. So that's going to be just p plus 3. All right, now what can p not be equal to? So we go back to our denominators here and here. What would make p plus 3 equal to 0? That would be a negative 3. What would make 10p equal to 0? That would be if p is 0. So our p cannot be equal to negative 3 or 0. Okay, the next video, I'll do a few more examples. Let me know if you have questions.